People say ML like it's one thing, but ML has three different learning styles. And the difference is not just definitions, it's the kind of feedback you have while training. In this video, I'll give you a simple mental model. What feedback do you have? Answers, no answers, or rewards? That single question tells you the ML type. Welcome back. Today we are covering types of machine learning: supervised, unsupervised, reinforcement learning. By the end, you will know what data each needs, what output it gives, and where it's used in real products. Here's why this matters in real life. When a company hires for ML, they are not just hiring ML, they are hiring for a specific problem type. If it's supervised, they need labels and evaluation. If it's unsupervised, they need discovery and interpretation. If it's reinforcement, they need simulation, constraints, and long term optimization. Also, picking the wrong type can waste weeks. Example, trying reinforcement learning for a problem that already has clear historical labels, you end up training something expensive when a simple supervised model would have solved it. Your shortcut: labels, supervised; no labels, unsupervised; actions with rewards over time, reinforcement. Let's make this crystal clear. Supervised, data comes with correct answers, model learns to predict those answers. Unsupervised, data has no correct answers, algorithm finds structure. Reinforcement, no answer key, but you get a reward signal after actions. Model learns a strategy. The output changes too. Supervised outputs predictions, unsupervised outputs clusters or anomaly flags, reinforcement outputs a policy, basically a what should I do next strategy. Supervised learning is the most common in business. You have X, the inputs, and Y, the correct label. Model learns X to Y. One important point: the model does not memorize the data. It tries to learn patterns that generalize. That's why we always keep a test set, because the real test is performance on unseen data. Think of it like you practice with solutions, then you take a final exams on new questions. Classification predicts categories. Examples: spam detection, fraud, churn, sentiment, disease detection. Applications: inbox filtering, transaction monitoring, retention campaigns, auto routing tickets, inspection systems. Here's a practical way to recognize classifications. If the output can be written like a label, tag, or bucket, it's classification. Also, in many real systems, classification produces a probability first. Like fraud risk equals 0.93, then the system decides what to do. Regression predicts a number: house price, delivery ETA, sales forecast, demand forecast, credit risk score. Applications: pricing systems, logistics planning, inventory, forecasting, underwriting. Rule of thumb: if the output is on a number line and small differences matter, it's regression. Regression is also common in business because decision making often needs a number, not just yes or no. Supervised ML is not only training a model, it's a pipeline. Define label clearly, otherwise your model learns the wrong target. Clean data, missing values, duplicates, imbalance. Feature engineering: turn raw events into meaningful signals. Split train, validation, test, and for time-based problems, split by time. Train, tune, and evaluate. Metrics: classification, accuracy, precision, recall, F1, ROC, AUC. Regression, MAE, RMSE, R squared. But always translate to business impact. Coming to the pros of supervised learning: clear evaluation, mature tools, strong results when labels exist. Cons: labeling cost, bias in labels, data leakage risk, and drift over time. A common real-world issue is imbalance. Fraud can be 0.1% of transactions, so accuracy alone can lie. A model can be 99.9% accurate by predicting not fraud always. That's why precision and recall matter. Unsupervised learning means no labels, just inputs. Instead of predicting a known answer, you ask questions like: are there natural groups in my customers? Which products are similar? Is something behaving unusually? Unsupervised is often the starting point when you are exploring a new data set. Clustering groups similar items together. Customer segmentation is the classic example. You cluster users by frequency, spend, categories, engagement, and you might discover segments like high value loyal customers, seasonal buyers, discount driven customers, dormant users. Applications include targeting, personalization, catalog organization, and even building better strategies for supervised models later. Anomaly detection finds unusual points or patterns. Fraud spikes, bot behavior, machine falls, intrusion signals, sudden KPI drops. It's often used like a smoke alarm. It doesn't prove fire, but it tells you check this now. A key detail: false alarms are common, so anomaly detection works best when connected to an investigation workflow, not as a final judge. Dimensionality reduction compresses high dimensional data into fewer dimensions. Why it matters? Real datasets can have hundreds or thousands of features, hard to visualize, hard to cluster, and noisy. Reducing dimensionality can help reveal patterns and make tasks faster. Applications include visualization of segments, similarity search embeddings, and noise reduction before clustering. Pros of unsupervised learning: no labels needed, great for discovery, segmentation, anomalies, useful early in projects. Cons include validation is tricky, clusters may not mean anything without context, results can change with scaling and features. So, in unsupervised learning, the real skill is not just running the algorithm, it's interpreting results and connecting them to business decisions. Reinforcement learning is about decisions over time. Agent takes actions in an environment, gets a reward or penalty, learns a strategy that maximizes total reward. The important part is sequential decisions. Your action today changes what options you have tomorrow. So, reinforcement learning is not predict once, it's act, learn, act again with long term consequences. Agent, environment, state, action, reward, policy. Policy is the learned behavior, the agent's decision rule. Exploration versus exploitation is central. If you never explore, you never learn better actions. If you explore too much, you waste reward and may behave badly. In business settings, exploration must be controlled, safe, and often tested in simulations. Games and robotics are famous examples, but reinforcement learning ideas also show up in ad bidding, budget pacing, dynamic pricing, routing, scheduling. The theme is always the same: you're optimizing a sequence of actions under constraints, not just a single prediction. Pros of reinforcement learning is handles sequential decisions, optimizes long term reward, can outperform rule based systems. Cons include expensive training, unstable learning, hard debugging, reward design pitfalls, safety risks. Reward design is a big deal. If you reward the wrong thing, the agent can game the system. So, real reinforcement learning work includes constraints, monitoring, and careful evaluation. Supervised, learn from labels to predict outcomes. Unsupervised, find structure without labels, clusters, and anomalies. Reinforcement, learn actions through rewards to optimize decisions over time. What should I make next? Comment 1 or 2. Confusion matrix and thresholds, or customer segmentation project end to end. If this helped, don't forget to like and subscribe.